Yeah.
The Homely Grove Food Pantry needs to be filled for the holidays, so we're having a first period food drop. Bring canned food and non-perishable items to your first period class until November 26th. The winning class gets pizza after Thanksgiving break. See Ms. Solar for more information.
Definitely call us.
They went away. They were put you on a scale, but it still went to 24. So we're just calling wear ankles. They're not going to sit. He rocks.
There's no way you can move it, right?
You don't see?
No, she didn't.
Got it. No, what?
Y'all ready?
No.
G of x equals parentheses 1/2 x close parentheses to the fourth. You're welcome. Then it says stretch by 2 on the side. Everybody ready?
No. I'm on this side. Is that one thing?
1/4 x before Christmas.
I think it's one oh my bad. I didn't know if you saw it or not.
I think it's been sitting on this screen for long enough anyway. It's got a heavy head.
No warning.
How nice.
Oh yeah. Oh, you could have changed that. I don't know my phone. Yes, that's
I'm sure you don't get that earlier, but I wasn't sure.
I don't know why I did that.
Did you get it all?
Right, the last one.
Well, I can go, I got it. She's got it. Alright, so first thing we're going to do today, listen, first thing we're going to do today is work through a couple of transformations just by looking at the equations. Okay, then what we're going to do after that is we're going to go back through the same equations and look at them on the graph. So we get a little practice doing both. Okay, so just looking at the two equations that I have here. If I started you with f of x is equal to x cubed, but then I said, what did f of x do to become g of x? How would you describe the transformation that took place from f of x to g of x? Reading left to right, first thing you notice, x cubed, x. But then this one doesn't have anything else. This one's got a plus 5 in the parentheses. So that's the first thing you're checking on. And this has been the same for every type of function we've done. If there's something being added or subtracted in the parentheses with an x, what type of transformation is that?
horizontal.
Horizontal translation, very good. What is it about the sign in the parentheses on a horizontal?
It makes it go 5 units to the left.
Very good. It goes the opposite way. So we would say g of x moves 5 units to the left. Okay? Then we keep reading and we say we got a plus 2 stuck on the end. Anytime there's something added or subtracted on the very end, what type of transformation is that?
Vertical.
Vertical translation, up and down. What about the sign on that one?
It stays the same.
So this would go 2 units up. Okay? That there is not one new thing on that. Just the graphs would look different. These would actually make a graph that looks like a snake, and we're going to come back and pick that up in a minute. As far as all the transformations, it is exactly the same as every type of transformation we've done all year. Okay, everybody got that?
The reason it looks like a snake is because of the cube, right?
Mm-hmm. Ends going opposite directions. Very good. Okay. Y'all know, while I'm stalling here to let Gary get caught up, there's always 5 or 6 of these on every test talking about the transformations. So by now we will be experts at them. All right, this one starts us off here with f of x is equal to x to the 4th. And then I've got g of x is equal to negative 1/4 x to the 4th. Okay, so same question. What transformation took place from f of x to g of x? Okay, so first thing we come to is a negative that's different. So let's just work left to right and talk about the negative. It is, anytime there's a negative, there is a reflection, but it can be over different axes. So which reflection are we dealing with here? Okay, that negative, looking at your chart, that negative is out in front of the whole thing. So look at those examples over there on reflection. Is the negative in front of the whole thing or just in with the x?
It's the whole thing.
Whole thing. So which axis does that reflect over?
The Y.
Look at your chart. X-axis. Okay. Now next thing we come to after the negative is the 1/4. If there's no sign in between the 1/4 and the letter, that's multiplying. So anytime we're multiplying, we know we're horizontally or vertically shrinking or stretching. So go down to the last 2 rows on your chart. You're looking. Okay, you're looking to see, and look at the examples. In my opinion, on this chart, the examples are way more valuable than the notation. So look at the examples and look and see. We don't have a parentheses in ours. Which one of the examples is there no parentheses? And Lane Joe's already said it. Vertical, so we're down there in the vertical. Now what we're looking at on the vertical is in the examples, does it use the reciprocal or does it use the number like it is? It uses the number like it is. And so 1/4 is smaller than 1. Smaller would be a shrink. Okay? And we can get that straight off of the examples on our table, our chart we made. Okay, I got just maybe 2 more of these before we look at something else. Everybody got what we need on that one? Alright, this one says f of x equals x to the 5th, and we are going to come back before we get done and with the period and look at the graphs of all these. And then g of x is equal to 2x to the 5th minus 3. So what transformation took place from f to g?
Should go down 3.
Okay, it is going to go down 3. Let's get that 2 first, though. But here it's right. Okay. Okay. Now, why is Laney Joe saying a horizontal shrink? Because 2's bigger than 1. Horizontal is funny. Very good. How do we know it's horizontal? Okay, very good. That parentheses tells us that. So when you look down at the shrinking instruction, vertical doesn't have any parentheses anywhere, does it? So you see how they landed in the horizontal with the parentheses there? So that is a horizontal, and horizontal, like Chloe reminded us, is weird. So you take the reciprocal. The reciprocal of 2 is 1/2. 1/2 is smaller than 1. And then we got Garrett's 3 units down with that minus 3 stuck on the end. Okey-dokey. Alright, last top of that I want us to look at. Everybody good? Alright, last top of that I want us to look at. This says g of x is equal to f of negative x. So this is weird. Our directions have changed a little bit. So what I'm given in the beginning is what f of x is. So for this particular problem, it could be anything, but for this particular problem, f of x is x cubed plus x squared plus 1. Okay, so there's your function. F of x is x cubed plus x squared plus 1. So what this stuff over here on the left wants us to do, it wants us to take my f of x, and obviously it's got a negative, so it wants me to reflect. Okay, and that negative is in the parentheses. So looking at my examples on reflection, I see in the parentheses is the y-axis, right? Everybody see that? So it's wanting me to write a function for what g of x would be if I reflected this over the y-axis.
Would all your x's change to negative?
Yes, they would. Very good. So what we're going to do to start this off is every one of these x's in here, like Laney Joe said, we're going to have to initially put a negative. Now, that's going to make some weird things happen. And it all has to do with negatives and powers, because you can simplify this a little bit. What do you get if you cube a negative? That means a negative times a negative times a negative. What will your answer be? It'll stay a negative. A negative times a negative is a positive, but then times another negative turns it back to a negative. So this first one would be negative x cubed. What about right here with my x squared? What's a negative times a negative? So that turns that to a positive x squared. And then there's your plus 1. So that would be your answer for that.
So it's this.
Weird a little bit, huh?
Yeah, a little bit.
How did that?
How do people make sense of it? Like, I don't understand how people just thought, like, one day, like, this is what they were going to have to do.
Who got to just make all these math decisions? Why didn't we get consulted? We could have simplified it up. Okay, so I'm going to rewind us. Everybody got what we need on that page? Rewind us. Oops, that was last period. There we go. All right, now we're going to look at the graphs of these. And I'm going to talk to you about how to do them both by hand and on the calculator, so be patient with me as we go through all of it. First off, a couple of things that we already know about the characteristics of this graph. And Grant pointed this out earlier. This is an odd degree. Odd degree means your ends go in opposite directions. My leading coefficient's positive, so it's going to go uphill first. There's nothing being added or subtracted, so I know it's going to go through the origin. So if I just had to give a rough idea of what this graph would look like, and we're going to look at it in just a second, it's going to go through the origin. It's got to go in opposite directions, so it's probably going to look something like that. Now, how could I get some more specific points on that graph? Very good. You go in old school, make your input-output table. I already did 0. If I plug the 0 in for the x, 0 cubed is 0. What if I plug the 1 in for the x? 1 cubed is 1. So that means over 1, up 1. Okay. What about if I did negative 1 cubed? What's negative 1 times negative 1 times negative 1? Okay. What about if I did 2 cubed?
8.
Okay, so it makes a big jump on that. So that would be going way up there. So then you know negative 2 cubed would be negative 8. So that would be coming way down there. Okay, you can make that input-output table on both of those. Or you could take these points, move them 5 units left and 2 units up. So once I get my original function graph, I could move each of these points 5 units left and 2 units up. And I would see that same graph over there, right?
So which one's the right one?
Well, both. I've got f of x and g of x.
Okay.
I've got 2 graphs on there. Now, on your calculator, I've got mine under the ladybug so we can make sure we know how to type it on. Oh, yeah. Okay, everybody got your calculator ready? I know you already know, but there might be 1 or 2 of us that need to go through the steps, so I need to turn that on. If I'm fixing to start doing some graphing here, what area, what part of the calculator is going to be super important to me?
Right. Y equals.
Okay, this whole line right underneath the screen, these are your graphing buttons. So if we're graphing something, we're on that whole line right underneath the screen. And the y equals is the same as f of x. So as long as your equation says either y equals or f of x equals or g of x equals, you're good. So this very top one right here, hit y equals. If you've got anything in there, clear it out. Now we're going to put both of those first 2 functions in one at a time to start with. Okay, so the first one that we did was just x cubed. Your x button, right there underneath the mode, see it says x, t, theta, n, that's your x button. So I'm going to get x. Then to get a cube, over here on the far right underneath the clear, see that carrot top or rooftop? See that? That brings it to your power. And then I want cubed.
Oh.
Okay? That's all I want right now, so I'm just going to hit graph. See where graph is up here on your graphing buttons?
I got exactly what you got.
Okay, now that's pretty good. If you don't get that, let me know if you need help on that. That's pretty good, but that's not the most useful part of this. The most useful part of this is the table. That input-output table that I was making over there behind Michaela on the dry erase board. I've got an infinite input-output table for every number you want in the calculator. So you can hit second, and then look where the graph button is. Right above it, it says table. So I'm going to hit second, table. And I can find any ordered pair on that entire graph that I want.
Dang, that's cool.
You can scroll up to see some negatives. You can scroll down to keep going. Now let me caution you this, because this happens every year. You're going to start scrolling down. Garrett's probably already doing it. And you're going to get down to the 7,000s in your X. Guess what? This next graph that I ask you for in a minute, that's where your X is going to be.
How are you going to graph that?
You're the one scrolling, so you're the one that has to figure it out.
Dang. You have to scroll.
But you can go, I could scroll it up to see if I got my -1 and -2 right. You can check any points in there you want. Okay? Everybody good on that first one? Now I'm going to hit, you can get out of the screen a lot of ways. I'm just going to hit y equals because I just want to go back and on that same screen, shh, y'all be quiet. On that same screen, I want to add the g of x to see if my picture over here behind Michaela looks right or not. So I'm going to go leave f of x on there. I'm going to compare them. I'm going to go down here. G of x and it has in parentheses. This is out of your notes. X plus 5. Close the parentheses. Raise that to the third power. And then plus 2. Is that what was next? So when to bring it down from the power, I got to arrow over. See that? And then plus 2.
Oh.
Did I get it all in correct? Yep. So hit graph. And it's going to graph them in order. So it'll do y1 first, your x cubed first. If it's already there, then there's the second one. Now, pretty smooth comparison on that. Again, what's most useful on a test and assignment is being able to go to your table. And this is pretty cool here. Because on my f of x, when x was 0, y was 0. But on my g of x, when x was 0, y was 127. So that means on this graph right here, if I'm trying to find g of x and I go over 0, I would have to go up to 127 before this thing inches that far over there. Because it's just barely getting wider.
That'd be a big graph.
Yeah, very good. All right, everybody good on that?
We need to draw the graph.
It wouldn't hurt you to have an idea, but it's not necessary.
No, it's not. It's just making it.
Okay, so
Our notes.
now for this one, Riley, my answer is going to be yes. I want you can use your calculator. You can use your calculator if you want to, but you don't have to. I want you to give me an idea of what those graphs would look like and some points out of the table. Either your manual table like I did on the dry erase board, or use the table function on your calculator. I want the graphs of those and some points for each of them. Yeah, all these are the ones where you wrote down. Now you're graphing. Yeah. I would clear out the first two that we did.
That's one of the first. What did you eat? This is what I got.
This is what I got when I put both together.
You're not supposed to put.
Yes, you are.
Oh, see, we still got the same answer though. Because I got the top one and you got the bottom one. So either way.
Yeah, you've got just the top one and some more. Yep, that's good. If I need help on the calculator, let me know now. Well, we got to see Jacob. Hit alpha, y, equals here. That is a non-saver for me.
Saver.
Everybody good?
She's not so petty about it.
You know what I'm saying?
Wait, what did you get? Can we write down
No, I mean, you can't write down the table because it goes infinite, but just write down a few of them. Okay, so I've got mine typed in. Get grabbed. There goes the first one. And there goes the second one. Now, those appear to be parabolas. Are they true parabolas?
No.
Why not? Okay, the power is to the fourth. And so what actually happens there, that vertex on the parabola that comes to 1 point, on this thing it would flatten out a little bit more. It would stay there a little bit longer. It wouldn't just go to the 1 point and stop. Can you tell the one that they're not the same width? You see that? And that's important because this one had a 1/4 out in front, changing the width of one of them, right? So everybody good on that? Now, this happens every time when we start doing these. If you type something in your calculator and you think you got it all typed in right and you're not seeing something, and I'm not going to do this for you on a test, so you need to know how to problem solve. Number one thing to always check for is somebody on another class probably screwed up your zoom. So see where your zoom button is? Push that. Let's look at it. Zoom. There's lots of stuff in there, but number 6. If you're taking the ACT, if you're in here and somebody screwed up your calculator, zoom 6 will always take you back to the standard window. The standard window is that 10 by 10. Okay, that's what's on your screen right now. It's a 10 by 10. So if you've got a graph that has humongo numbers, if you're not going to see it on a 10 by 10, that's when you would start playing with the zoom and zooming out and changing your window and all that kind of stuff. Okay? All right, I think we got one more to look at, don't we, or there's 2? Yeah, they do. You're right, CJ. Alright, so the next one we looked at was that one. Go. Clear out those last 2.
Got it.
Garrett, you got them?
Yes, we're getting them.
Garrett, that's right.
But I don't have what?
We're doing the right problem.
I know I'm doing it right now.
Yay.
Oh my gosh, that overlap.
Every time I graph these by hand, I make an input-output table. Now you've got the input-output table at your disposal. You can pick any point you want. Man, that'd be a nightmare graph. Negative 7,776. Just got that on.
When it's on the test, we gotta graph that?
I wouldn't choose that one. I'd choose something I could count to.
So like 1 and 1 and 2 and 32?
Those would be better than 7,776.
I can't even count that high.
No. Allergies is easy to forget.
25. I was reading.
Alright, how'd you do?
Bored.
Get something similar to that. That's hard to look at when you just see it up there like that. But what you'll need to pay attention to, if you put more than one graph at a time like we're doing right now, when you put more than one in at a time and hit graph, it will draw them in the order you put them in. So you need to pay attention to that. Kind of watch the first graph appear, and then watch the second graph. Because now if you turn away and then just look back up there, you don't know what's going on that. That's kind of confusing looking. Okay?
So it won't come out.
Alright, so
Yeah, I got it.
go ahead. Let me highlight what I want for you to do out of this. Where's my highlight? There it is.
Is that rain?
It was the error.
I don't know if I asked the question.
Alright. Graph the two functions there. Do the f of x one up there in the top right, and then do the g of x one down there.
Shut up. Wait, how do I get an F? Oh! Shut up. Okay. Oh. God.
Kind of really looks like two parabolas.
Yeah, it does, if you just looked at that.
That's what she just said.
Yeah, that would be really confusing if you
Yep,
wanted to watch that.
that's right. Alright, here's what I had, and what I wanted to talk about is exactly what I heard CJ and Grant talking about. Shh, y'all be quiet. If I just put that like that on a test and gave you that, this would give the appearance of maybe two quadratics or two functions to the fourth power. That's why I told you it's super duper important that you pay attention as it draws, because that's definitely not what drew, is it? Did you watch it when it drew? Which, the positive ones first. So it started here and drew that one first. Had that snake going uphill first, right? And then this one was a snake coming downhill second. And that's important that you know what you're graphing, because it's got to be ends going in different directions. You got to catch on all that. All right, let me tell you where we're headed this week with everything. Friday is when we're going to take a test over this. We got maybe one more thing to talk about, but tomorrow I have to be at a meeting in Arkadelphia, so we can't talk about it tomorrow. So you're going to work on your study guide tomorrow. And then when I get back, we'll talk about that last thing we need to talk about. And then we'll go over the study guide and we'll do the test on Friday. Alright, everybody else alright while Riley figures that out?
Yes, ma'am. We're gonna miss you tomorrow.
I bet you